Si están de acuerdo, vamos a empezar unos minutitos más. Digo, vamos a esperar unos minutitos más, unos 3 minutitos, 4 más para darle oportunidad a las personas a que se conecten y ya empezamos. So, Brian, if you are okay with it, we're going to wait a few more minutes, like 2 or 3 more minutes for more people to connect to the call.
That sounds great. Thank you.
Thank you.
Ryan, doing good?
Doing good. Yes.
Awesome, awesome. What is that patch you have in your t-shirt?
Oh yeah. NASA docking systems. Yeah. It's a
Oh, okay.
that was a fun one. Yeah. It's a project I got to work a long time ago. So
Yeah.
had kind of an important meeting at work today, and so I like to I like to wear it to those. One of my favorite shirts.
Yeah, you bet. Awesome. Thanks for joining, Brian.
Yeah, I'm excited to be here.
Are you sharing your screen, Brian, as well?
I'm not yet. Would you like me to?
I just want to make sure that you have share rights.
Sure. Yeah, let me get it set up. Let's see. Duplicate. Yeah, I need to configure it a little bit. So I got two screens, but I need it to not be on the main one, I think, or Zoom will act weird. Right, am I sharing?
Yes.
All right.
Feliz 5 de Mayo.
Yeah.
Okay, everyone. So, digo, hola a todos. Si escuchan por ahí un llanto, es mi bebé. Este, hola a todos, buenas tardes. Muchas gracias por conectarse a esta que es la primera de nuestras 5 sesiones. Perdón, si son 5 o son 4.
Cuatro.
4, 4. Pues nuestras 4 sesiones de conferencias para adentrarnos más en esta experiencia del ISS MIMIC. Em, Muchas gracias, Javier y Brian. Thank you, Javier and Brian, for being here. Em, Hoy vamos a platicar con Brian Murphy, que muchos de ustedes ya conocen, que ya nos habíamos reunido con él anteriormente, quien es pues uno de los responsables de este proyecto de la ISS MIMIC. Y pues nos va a platicar en esta primera sesión, pues cómo fue imaginar este proyecto y la importancia que tiene pues utilizar la estación espacial como un medio de divulgación de la ciencia espacial. Yo voy a estar aquí de alguna forma apoyando un poco a traducir eh, en algunos momentos, si lo requieren, y pues acompañándoles. No sé, Javier, si quieres decir algo antes de que le traduzca un poco a Brian lo que acabo de decir.
Ok, claro que sí. Muchas gracias, Ana Cristina, por hacer este puente de enlace con el Instituto Politécnico Nacional. Nos llena mucho de orgullo estar frente a todos ustedes y nos da mucho orgullo y placer que ustedes estén tomando este tiempo para poder trabajar con nosotros. Yo soy parte del equipo de ISS MIMIC. La parte mía se encarga de hacer que este proyecto salga fuera de las fronteras de Estados Unidos y gracias a la alianza que tenemos con Ana y con el Instituto Politécnico Nacional, ahora este es un sueño hecho realidad en México. Tenemos diferentes MIMICs en diferentes países. Tenemos entre ellos incluido Brasil, Colombia, México. En México tenemos 3 o 4, me parece. Tenemos Canadá, Japón, Estonia, Sudáfrica y no sé si alguno se me queda por el tintero. Estos son gracias al esfuerzo que ha hecho Brian y a todo el equipo. Él le llama con mucho cariño los Mimickers, porque son un grupo de voluntarios que hicieron esto. Él les va a platicar un poquito más desde su corazón. Y otra cosa muy importante es que ellos están muy motivados y felices de estar trabajando con ustedes porque la parte de ellos es la parte de ingeniería, pero ellos siempre han dicho que se requiere un buen comunicólogo, un buen profesor para que proyectos como este puedan llegar más allá y tengan un impacto en nuestra comunidad. Así es que muchas gracias a todos.
Gracias, Javier. So, Brian, I was just introducing a little bit of you, but you can complete a little bit more of your introduction and telling them that these will be the first of our 4 sessions that we planned to get them more immersed in the ISS Mimic experience. And this will be like the amuse bouche, the introduction on how you envisioned this project and why is it important to use the International Space Station for outreach and to involve more people into space science. So thank you very much, Brian, for your time and your effort in this presentation. And please go ahead. Thank you.
Yeah, thank you so much for having me. I'm very excited to be here with you. I'm very excited about what's going on around the world and in Mexico specifically today. So thank you so much for having me. Do you want me to pause for translating, or how would you like to handle that?
Oh yes, I'll be translating a little bit
Okay.
unless everyone agrees that they don't need translation. Let me ask. Colegas, ¿necesitan que vaya traduciendo? ¿Es mejor o lo dejamos así todo en inglés?
Por mí puede ser en inglés, no hay ningún problema.
Así puede estar bien,
English.
gracias. De igual manera, en inglés está bien.
Ok, si alguien más quiere escribir en el chat o si quieren levantar su manita, si prefieren que sea que traduzca, pueden levantar su manita. Ok, entonces lo dejamos en inglés y si alguien tiene alguna pregunta, algo que no hayan entendido, pues nos pueden preguntar y les traducimos. So they say they don't need translation, so if they have some
Okay.
questions or anything, they'll ask and we can translate or explain a little bit further.
Wonderful. That sounds great. Speaking of questions, please stop me anytime and ask as we go. I'm not going to watch the chat, so I don't know if you or Javier could just, interrupt me and ask questions, or if people want to come off mute and ask questions, I'm fine with any of that. Okay? Okay, great. Great. Well, yes, as was mentioned, I'm Brian Murphy. I'm here in Houston. I work for a company that does, all kinds of work for space, specifically the space station. I went to college. So let's see, I grew up on a farm, a small farm in North Texas, uh, a really small town. There were 19 people in my graduating high school class. And then from there, I went to Texas A&M University, where I studied mechanical engineering. When I was a kid growing up on a farm, I really liked all the mechanical things. So we grew peaches and vegetables. That was our livelihood. That's what my parents decided to do. They actually were in Houston, moved to the middle of nowhere to have this farm and raise us kids. And that's still where they live. And then I moved to Houston for this job. But yeah, so I went to college. I studied mechanical engineering. I got a bachelor's degree and I stayed for a master's degree. I actually never was looking to work in space. It wasn't a goal of mine. I liked robotics and mechanisms and things like that. And when I was in college, my wife and I, she was also an engineer and we were looking for jobs together. And this is one of the places that offered both of us jobs. So we said, hey, let's try it out. And now here, over 20 years later, we're still here. And now I love space so much, as you can probably tell. Okay, so that's about me. And now I'll talk a little about the project. So the origin story of ISS MIMIC. So a long time ago, in a galaxy right here, this galaxy, this is where it started, here on Earth. I started working in 2004. So this at the top is what the space station looked like in 2004. It had just started being assembled. There weren't very many pieces yet. Actually, the year before, in 2003, is when the Columbia disaster occurred, which is when the space shuttle, upon reentry, came apart and we lost the crew. I was still in college at the time, and even then, like I mentioned, I wasn't planning anything to do in space. I wasn't planning to work in that industry, and so I didn't know that a year later, almost a year to the day after that occurred, I would start working on the space station. So this is what it looked like then, and then the bottom is when it looked like in 2011. And that's important because that's when the space shuttle retired. So the space station you see now today looks a lot like this one in 2011. There are some differences, but they're pretty minor. But this is what it looked like. So in that short period of time, it grew so much as we added more and more elements and built it out to the powerhouse it is today. Enabling so much science to be done from people from around the world. So around that time, though, that was when the space shuttle retired. A lot of people thought, even in the US, thought that we were basically done exploring space. And what I realized at the time, in around 2012, is when we were expecting my daughter. And I remember thinking how fortunate we were that she was going to grow up with all kinds of STEM opportunities here in Houston, at a much bigger school than I went to when I was a kid. She's always going to know that humanity is doing things in space. Her mom's an engineer and an artist, an incredible person. She has examples all around her of people that are participating in what we're doing in space. But then I imagined if we had lived somewhere else, if she had just been born almost anywhere else, or even in Houston, but in a different part of Houston, or in some country on the other side of the world, she wouldn't even know maybe that what's going on in space. And I just felt like that was such a shame because the space station in particular is something where humanity has come together to pool our resources, our funds, our time, our energy, our focus, our skills to create this incredible laboratory that's orbiting the Earth that we can do all kinds of unique science experiments on. And then we learn more about ourselves, our human bodies, and how we live on this earth and the technologies we can create, right? All this exciting stuff, but most people are completely disconnected from that, which is so sad. So the inspiration came when NASA announced a public data feed from the space station. And so that's when it clicked in my mind, well, we need to do something with this data coming from space station. And so this is from 2012. This was when I first had the idea. This is all that I had at that point. These are some things I wrote up. And I remember this fondly now because it's come so far and it's been able to impact many people, not because of me, but because of others who have brought this forward. So this is what I had. It didn't even have a name yet. You'll notice it keeps saying mimic, 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 but I didn't name it mimic yet. But this is the same photo pretty much of the one I just showed, which has these little markers are where the solar panels can rotate. And so my idea at first was, well, let's just make something where these solar panels can rotate. Is my marker? Okay, let me get annotation going. Sorry, annotate. Laser pointer. Is that? Yeah. Okay. Can't tell. Is that coming through? You seeing my dot? Yeah. Okay. Yeah. So these are where the motors can rotate. And so really that was the only idea I had at the time. And so these are some like different things that could be done. What do we need to do? Well, we need to pull the data from this website. We'll send it to an Arduino, all these different things, right? I kind of show it as a picture here. So this screenshot is from a website that NASA had that was showing these different data pieces. And so I was thinking we would just pull from that. This shows how long ago it was. Look at this cell phone. Right? And then this is a simplified idea of how we would do it. And then we use a 3D printed model. And it would be that simple, right? It was not that simple. So this was 2012. This was the year my daughter was born that I had the idea. But for the next several years, nothing happened. I mentioned it to a couple people, but it's a big project to try to take on. And nothing, never went anywhere. Of course, I was home with, or not home, but we had 2 young kids at home and not a lot of time. And then finally in 2015, I told some other space nerds about it. And what's interesting is these are people that are at the same company as me, right? But I really didn't know them. And you'd never know it now because we're buddies. But some of you may have met or heard, about Craig or Sam. Those are 2 of the very first ones we talked about. So in 2015, that's when I shared the idea with them. And that's when we started development. So this is the first time anyone saw it outside of those of us who were working on it. This was what the first piece looked like. So this is just what we call the outboard truss, right? So this is just one end of the space station and it can rotate and this is what that looked like. So this was the first time we did any kind of outreach. Very fittingly, this was to some teachers. NASA has a program called the Extern Project that teachers can apply for. And then those teachers get to visit NASA, but then they also get to visit a lot of the companies that do work for NASA. So that's what this was. And then this is the first time we ever took it out of the building and took it to an event with students. So we actually went to Galveston with this, but this was not Amy's school. Hadn't met Amy yet. This was a different high school in Galveston. So this is what it looked like back then. You can kind of tell we only have solar panels on one side. There's no solar panels here. It was still very early on, but it was a lot of fun already. So that was early 2019. And then this is the first time we took it to a conference. So this was at the Space Exploration Educator Conference that's at Space Center Houston every year. And I've met some really amazing people there, including some on this call. So this is us presenting there at Space Center Houston. And let's see. And you may notice a certain person that was in attendance that day. 2020. That's Amy Medina. Didn't know that our world was going to change. Not for a while though. Okay. And then this is in the summer of 2022. NASA had another of their extern programs. And then someone showed up again. And by the way, she had a lot of fun over here doing our VR thing as well. But we had no idea that, we remembered her from the event before, but had no idea that she had moved to Houston. She was now teaching in Houston. And so this is kind of what's really started things off for the project becoming more than just a little hobby thing where we engineers really weren't able to take it out much for the world to see, to actually live out its purpose. So I'll pause here and just say, the purpose of the project of ISS Mimic is to achieve those things that we see missing, right? One is just the connection from what humanity is doing in space to what all of us here on Earth, because it is a combined effort from so many countries working together to make that happen. But much more important than that is just helping people realize that they can do this. Having students and teachers realize you're capable of all these things, all these skills that go into building a mimic model, and for the students to realize that all those skills they learn building a mimic model, things like coding, robotics, wiring, mechatronics, 3D printing, problem solving, getting really frustrated when it doesn't work, and then it finally works, that skill of resilience, those are skills we use every day. We, meaning space engineers, use every day to support the real space station. So we want this project to do that for them. We want this project to break through barriers, to let them have the epiphany that they can do this. And not just because they can do it, not just to prove that they can do it, but just like we want our students to learn art and music, not necessarily because we want them to become professional artists or professional musicians. This is creating. This is enjoying part of life. I feel like STEM and science are the same. You don't have to become an engineer. You can do the project and just enjoy that, right? That's just a whole aspect of life. It's like the very building blocks of the universe, the things we're learning about ourselves from the space station, all this new technology, all the science, all these discoveries. Once we know these things like coding and robotics, well, now we can create. And so once you realize you're capable of creating, well, that's a lot of fun, right? So I hope people do it because it's fun, not because they're chasing a STEM career. If they want to become a STEM professional, that's great too. Okay. And now this is the first time we ever built one of these with students. I'll say this was a challenge. This is a local library, Freeman Library. It's just a couple miles from where I am right now, really close to Johnson Space Center, to NASA. These faces, these smiles are right after we turned on the live data for the first time it ever mimicked. And what you don't see here is they spent 12 weeks building this. All of these students and all of their parents. We made the parents help as well. So they had there was no prerequisite. There was no, you need to come with these skills. It was just like, anyone that wants, come. We're going to teach you different things. In this case, we taught soldering, coding, using a Raspberry Pi, working with motors, some 3D printing, a lot of hands-on building, but also we gave a lot of help. We gave a lot of help. And this was part of what showed us that this particular Mimic, this style build, this was our original, was too much to take on. Too big for a classroom, too big of a project for a classroom to take on. But this was a lot of fun, and just soak in those smiles. I have this photo on my wall at work. This is one of the best days of my life. I also really want to point this out. So up until this point, 8 years after we started, 8 years, ISS Mimic had never left Houston. But the key part of that is we'd also never partnered with teachers. We knew curriculum was our weakest part, but we had no idea what was coming with these teachers. What I'm showing here is it's raining mimics now from Amy and Javier, what they've done for this project. And you educators out there, you guys are the superstars. You guys that are putting in this extra work, giving yourself extra headaches, choosing to do these projects that are a challenge and different, and maybe the instructions aren't clear. But you're doing this for your students, and it's amazing, and we are so thankful. I think I have some more embarrassing photos. So here's Amy and Javier winning the Cherie Brinkley Award back-to-back years at Seek, huh? Right? And then, yeah, okay. And then I have more history on Mimic as well. So after partnering with these teachers, let me move. We've had so many more outreach opportunities. So this is that build. This is when we built that with the students. This is when Amy joined us for the first time at Seek. She presented with us. And she came up with this cool miniature solar array wing project for teachers to get used to coding on. This page is from our GitHub that has all the code in CAD. But it's also where we house this timeline. And we don't have everything listed here. We need, if you guys have photos, or if you end up taking photos in your classroom and the things we can share, we'd love to post these on here and celebrate with you. But this International Aerospace Academy has just been transformative. What Javier has done with that to get the global reach. I mean, all the countries he mentioned are really from that. This was a fun thing where we got interviewed by Joel Telling, a 3D printing nerd from YouTube. We've had a lot of fun activities. We did go to Amy's school, Odyssey Academy, and had a fun time there. Yeah, we've had many opportunities with these guys. The media tours. You guys know Amy and Javier are just amazing. I think Amy's preparing for her zero-G flight tomorrow, so it's hard to embarrass her. But Javier's on, so I'm happy to embarrass him. So the working with these teachers has really begun to help us live out our dream for this project, which really is put this in the hands of teachers and empower the teachers so that they can then equip their kids and empower their kids. So, yeah, on behalf of kind of the engineering volunteers that started this project, just really want to say thank you to Amy and Javier and now to Anna and all these others that are going to bring this to your students or in your communities. It's overwhelming. It's beyond what we dreamed, but we're ready to keep pushing and reach more and more and more. Also, we're not going to stop with just ISS. We have plans to try to mimic other vehicles as they become available. So we're excited about that. We're excited about continuing to work with all of you in the future and just keep this team up of space engineers and teachers to help cultivate this among other teachers and students. All right, bring your questions.
Awesome. Thank you, Brian. ¿Algunas preguntas por parte del auditorio? Ana.
No sé, Javier, si quieras como explicarles un poco lo que tú y Amy han hecho, porque pues aquí no los conocen muy bien, entonces para tener como ese contexto.
Ok, perfecto. Bueno, Amy y yo somos dos educadores aquí del área de Houston. Yo trabajo en Brazosport ISD y Amy trabaja en Galveston. Lo que Brian se estaba refiriendo es que nosotros hemos trabajado con ISS MIMIC y como él dijo, por 8 años el proyecto no salió fuera de Houston. Entonces fue gracias al proyecto en colaboración que tenemos con profesores que pudimos sacar fuera del área de Houston este proyecto. Entonces nos llena mucho de orgullo. Yo soy director ejecutivo de un programa, de una organización sin fines de lucro, de la cual Ana también nos ayuda en el área de comunicación y todo eso. Es el International Aerospace Academy y dentro de ese programa tenemos un programa que se llama Orbital Learning Alliance, que se trata de juntar estas organizaciones que tienen proyectos como el de ISS MIMIC y juntarlos con estudiantes que tienen el interés. Entonces, conectamos el talento con oportunidades para que proyectos como ISS MIMIC puedan llegar fuera de este mundo, incluso como ya lo estamos viendo ahorita gracias al Politécnico, estamos teniendo ese lazo tan activo y nos llena mucho de orgullo de que ustedes ahora formen parte de este gran equipo. ¿Alguna pregunta por parte del auditorio? Ajá, Sofía,
Sí, gracias.
si
Buenas
quieres a mí
tardes.
o a Brian.
¿Sí me escuchas?
Sí.
Sí. Ah, ok. Bueno, mi, mi pregunta es, ¿de qué tamaño ha sido eh, la escala más grande que se ha hecho de la réplica de IS Mimic y cuántas partes móviles ha tenido esta? En, es decir, hasta cuánto podríamos, escalar haciéndolo factible para los estudiantes. Ujú.
Okay, Brian, she's asking what is the scale, the maximum scale you have enlarged the ISS Mimic, and how many moving pieces the Mimic has?
Good questions. The large one is 1% scale. It's about 3.5 feet long. 1%, 1/100th.
Ujú.
And moving parts, there are 8 individual solar arrays that turn, and then they also all turn together. And then there's 2 radiators that turn, so 12 altogether. 12 motors, 12 moving parts. 12.
And the mini Mimic?
The mini Mimic, it also has 12 moving parts, but it's half the scale. So it's, yeah, 0.5%. You can translate if that's helpful, Javier. 1/200th.
Ok. Tenemos dos versiones, una que es 1:100 y la otra es 0.5:100. Tenemos una versión que es grande, la Mimic, que le llamamos Big Mimic, y tenemos otra versión que es la mitad de la Big Mimic, que le llamamos Mini Mimic. Y hicimos este proyecto, el de Mini Mimic, porque el proyecto de la Estación Espacial Internacional Grande, que es de la escala de 1:100, se veía como muy imponente ante profesores. Entonces, no muchos profesores querían entrarle a ese proyecto. Entonces, hicimos una escala más pequeña, más reducida, para que tanto estudiantes como profesores pudieran tener esta oportunidad de ensamblarlo y, si se sienten cómodos, hacer la versión que es un poquito más grande y más compleja, y tiene 12 motores por cada modelo.
Ok. Mi pregunta era por si había alguna versión del ISMIC, por ejemplo, que tuviera el Canadarm, que fuera posible que hiciera así, tal cual el real, ajá, que no sé, que tomara un astronauta y lo moviera de un lugar a otro, así,
Ujú.
sería lindísimo, ¿no? Entonces, no sé si podríamos, al menos, no sé, como proyecto institucional, entonces al menos intentarlo. Ujú,
Sí, claro. Yo también quiero intentar ese proyecto del Canadá. De hecho, ahí tengo
ujú.
los CADs del modelo 3D. Sí se necesitaría hacerlo un poquito más grande, pero igual a ver si podemos coordinar algo o ustedes vayan avanzando y lo vamos viendo. Lo que tenemos en el ISS Mimic es una pantalla, y uno de los datos que tenemos desplegados es cuando el Canadarm está moviéndose para hacer algunas maniobras en el espacio. Tenemos un grupo en Discord, y ese grupo en Discord, cuando hay algo que va a ocurrir que tenga que ver con el ISS Mimic, empieza a mandar avisos. Entonces, hay veces que empieza a mandar avisos que el Canadarm se va a mover o se está moviendo. Entonces, yo ahí voy de chismoso a ver la pantalla para ver qué es lo que está ocurriendo y si se tienen diferentes valores de rotación. She's asking Brian about the Canada arm, that it would be neat if there's like a future development on that. I told her that I'm interested. I have the cats, and I'm interested in developing one day that project. And I was telling her that there's data that comes from Discord. So whenever there's like a motion that is going to be happening that is related to the ISS Mimic, there's this channel where you can see it. And I told her that whenever the Canadarm is about to move or is moving, those coordinates are being seen in the screen.
Yes. Yeah, we do have access to those. Canada Arm is something we've thought about a lot. We'd love to do it. It's so small, right? It's smaller than this, smaller than my fingers. So we may have to make a larger scale version that just does its own thing. It's not the same scale as Mimic, but we would love to do something like that. Canada Arm is amazing.
Ujú. Bueno, se pudiera hacer una colaboración con el IPN, que pudieran desarrollar ese proyecto en conjunto, y lo vamos viendo. Eh, otro,
Mm.
otro modelo que tiene Mimic es una antena que se tiene en el chasis del ISS, y se mueve también dependiendo de la dirección en donde se encuentre la Estación Espacial Internacional. Entonces también tienen ese modelo articulado. I was telling her about the antenna that you have
Oh, right.
that is articulated as well.
Yes. Yeah, that's fun. We may have a photo of that. We need more videos.
Yes. I might have it somewhere.
You might have it, yeah.
Mm.
I'll see if I can find a photo.
¿Alguna otra pregunta mientras Brian trata de encontrar la foto?
los LEDs, por ejemplo, yo sé que eh, empezaron a usarse en, en la Estación Espacial Internacional para beneficio de los mismos tripulantes, para su mejor descanso y para su mejor concentración. Eh, en, en el modelo a escala, ¿tienen alguna otra función además de solo meramente iluminar?
Ok, en los modelos LEDs que tenemos para la Estación Espacial Internacional de tamaño grande, es que se iluminan dependiendo de donde esté la Estación Espacial Internacional. Los colores cambian. Por ejemplo, si es de día, en donde está pasando, por el momento, si hay luz en esa es parte del planeta, se pintan de un color y cuando es de noche se pintan de otro color. Brian, she was asking about the changes in the LED lights. I was telling her about whenever the International Space Station was moving towards the part of the planet where there's light, there's one color, and when there's dark, there's another color.
Yes. Yeah, the LEDs are responding to the voltage level of the batteries. So you can tell just by looking at the LEDs if the solar panels are facing the sun or if they're not. So if they're kind of like Javier was saying, if the solar arrays are one color, you know that they must be behind the earth. It must be nighttime. So the LEDs that you saw are only in the original version. We still need to add those to the mini mimic and to the EDU version. So that's forward work. That's things that we're still working on to add.
Okay, we have another question here about
Thank you very much.
the moving parts and if they are made just in Arduino or in Raspberry Pi.
Okay. So yeah, so let's see if let me pull up another chart deck maybe. Give me just a moment. Trying to see if I have a good reference diagram handy. Kind of do. Okay. Let's see how I'm going to do this. I'm going to share again. Okay. I will share this one. All right. So, so this is how the data works. So it's using both the Raspberry Pi and an Arduino. So the Raspberry Pi grabs data from the streaming from the space station, and then it sends that data to an Arduino, and then the Arduino commands motors that make them turn. So you really need, the way we have it set up, you need both a Raspberry Pi and an Arduino in order for that to work. Does that make sense?
Yes, and can you tell them a little bit about the partnership that you have with Raspberry Pi?
Yes. Yeah, so let me stop this. Yeah, so yeah, another fortunate outcome from this is, yeah, we're now kind of teaming with the founders of Raspberry Pi. So Liz and Eben Upton have donated dozens of Raspberry Pis for us to give away to schools that are building mimics. And not only that, they usually I asked them to sign some of them, and so they've signed them and given those away. And now that we're kind of scaling up, it's too much for them to keep donating, but they're giving them to us at cost, basically at what it costs them to produce. And yeah, they've been great. Their social media, they highlight us quite a bit. We had some of them in town for Seek one year, and we got to take them on a VIP tour of NASA, and yeah, it's been a really great relationship.
Yeah, that was 2 years ago, right?
I guess it's only 2 years. It's been been a busy 2 years. Yes, 2 years ago.
Sí, entonces, una de las cosas que se tiene es esta alianza con Raspberry. Como dicen los fundadores, incluso han firmado los controladores de Raspberry. Tenemos dos controladores. El principal es el cerebro, que es un teclado más o menos como este. um, Algo así, un tecladito, y tiene aquí las terminales, que es el de Raspberry. Y tenemos el Shield, bueno, el Raspberry, que es más o menos como algo así. Entonces, se necesitan los dos para poder operar.
Is it blurring? I'll have to
Yep.
turn off blur. Okay. Yeah.
Ujú.
And this one, signed by Eben and Liz Upton.
Los fundadores de Raspberry. Ujú. ¿Alguna otra pregunta?
Perdón, una más. ¿La
Dale.
réplica que vamos a hacer va a incluir los dos tipos de panel, el SO y el airosa, o solo los tipos SO?
Son los dos.
Ok.
Ujú.
Y
Sí.
todos se mueven.
Sí, porque los iRosa y los paneles solares, los que siempre ha tenido, están unidos. Entonces, cuando se mueve uno, se mueve el otro. Mhm. Yeah, she was asking about the model that they're building, if they're going to have the all solar panels and the iRosas as well.
Yes. Are they doing minis? What are they doing?
Minis.
Minis, yeah. Okay. Great.
Yeah. ¿Qué otra pregunta tienen para Brian? Para mí o para Ana, que también está coordinando.
Em, Bueno, nosotros incluimos en nuestras actividades algunos enlaces nuevos a información de la misma NASA.
Ujú.
eh, bueno, esperando aumentar lo que es la introducción a cada tema, por ejemplo, de los paneles, o no sé si eso sea correcto para ustedes o no. Ujú.
Sí, está bien porque el proyecto es poder inspirar a estudiantes por medio de esta iniciativa. Entonces, mientras más ustedes le pongan, mientras más cosecha, que así de hecho se generó este proyecto, cada persona iba trayendo su experiencia, su liderazgo en el área en la que le correspondía. Entonces, así se fue armando este proyecto.
Ok.
Okay, so we have another question. Ok, para la unidad 3, ¿están en la unidad 3 en el Google Classroom? ¿A esa pregunta se refiere o será en la página de internet?
En la
Eh,
página, yo creo.
Ajá, ok. Sí, tenemos dos páginas de internet, se las voy a poner en el chat y ahí ustedes pueden ver todos los videos que hizo Amy, que la desarrolló con mucho trabajo, y viene la guía paso a paso para poder desarrollar este proyecto. Entonces se los paso aquí en el chat para que los tengan. ¿Qué otra pregunta?
bueno, yo soy muy preguntona.
Dale.
¿Cuál ha sido el espesor más pequeño que han podido imprimir sin que las piezas se fracturen? Porque cuando nosotros hicimos precisamente las réplicas de los paneles solares, pues queríamos hacerlo tal cual a escala, pero no era posible porque el espesor de la pieza hacía que se fracturara al momento de imprimirse. Entonces, o no sé qué material están ocupando que evite esa fractura.
Okay, she was asking about the solar panel and how the
The
thickness
thickness.
is fracturing. So she wants to know like if there's a modification on that, so they can print that. And next, I'm gonna tell her that next week is going to have more information on printing with Chen.
So she's trying to print them and they're not printing well? They're fracturing?
Yes, whenever cuando lo sacas, ¿verdad, Sofía?
Sí. Well, we want to make the piece
Mhm.
in a correct scale, but respect the thickness, we have a lot of difficulties because the piece broken frequently because was very tiny. And so I think that, well, I want to know if you use a special material for the tiny pieces.
We've printed it all just with PLA, which is probably what you're printing. Is that right? PLA?
Yes, and sometimes there's a modification that you can do on the infields because that's part of the learning curve that some other students have worked on, and they were doing different infields to print especially the solar panels because they're tricky because they are very thin.
Oh,
And whenever you pull them or whenever the nozzle is doing the zigzag for the infill, sometimes it makes like holes. So maybe if you change a little bit the infill, might work.
Javier, do you know, do we have recommended settings for printing there? I know we do for the original Mimic. And
I don't know about the mini mimic. Let me check.
okay. I have not had that particular problem.
¿Qué tipo de impresora están usando, Sofía?
I'm not sure. Let me ask to Emmanuel.
Es una impresora Creality, es la CR70 me parece.
Okay, so they're using a Creality, so it is a good one. Okay, voy a presentar mi pantalla. A ver si pueden ver esa.
De hecho, también hemos utilizado, bueno, se han hecho en distintas impresoras 3D. Tenemos una de que la cama es la que gira, una cama infinita, igual de Creality, y tenemos una pues de alta precisión, pero como lo comenta la autora, sí ha tenido algunos detalles las impresiones por ser tan delgadas, ¿no? Que llegan a fracturar o simplemente se despegan de la cama y ya no continúa la impresión. Entonces, bueno, ese ha sido algún detalle y hemos tenido que modificar algunas partes de la impresión, ¿no? En el caso.
Ok. ¿Están viendo mi pantalla del GitHub? ¿O están viendo la de Zoom? ¿Qué onda?
Se ve
Estamos viendo tu WhatsApp,
El
estamos
WhatsApp.
leyendo tus mensajes de WhatsApp.
Ah, ya ni sé dónde ando. A ver. Entonces estaba bien la pantalla.
So Sophia, are you printing with these settings?
Well, I'm not the person who do the printing.
Okay, that's
I
fine.
I help with the reduction and programmation.
Okay, I understand. Yeah, it may be that because this is a finer than normal height. This is shorter than normal. Normal you print 0.2. And so if you print 0.2, it may be that it doesn't come through and it needs to be 0.1. But it's looking like, Javier, it looks like we do have, I guess that's where it looks like we do have print settings listed for all the items in Mini,
Yeah.
hopefully. Some are missing, but I guess you would just use the same. Okay.
Entonces ahí en el GitHub, ahí les va a aparecerles. Can you share the GitHub link in the chat, Brian, please?
Sure. Yep. Oh, that's the wrong one. That's a different, if it's the solar arrays, here, this is the better one for that. Let's see. Yeah.
Thank you, thank you. ¿Qué más? ¿Qué más? Parece que ya, ¿no, Ana?
Pues sí, creo que eso sería por hoy.
Ujú.
I think that would be it, but thank you very much, Brian. This was a very inspiring conference today, and I'm sure it's a very good introduction for the next conferences that are going to be a little bit more in depth in the different components of the ISS Mimic and the modules that Javier and Amy developed. So thank you very much.
Yeah, I've really enjoyed it. Thanks so much for setting this up, Ana and Javier. I'm glad to be part of it. Yeah, and you're in for a real treat next week with Chen.
Thank you, thank you. Nuestra siguiente conferencia del ciclo va a ser el día lunes. ¿Sí, Ana? Creo que sí, ¿verdad? El día lunes. Les vamos a hacer llegar toda la información a través de Ana y ¿cómo se llama, Ana? DDICT.
De DICIT,
¿Cómo
de
se
DICIT
llama?
y el CDA. De DICIT, que es la Dirección de
Ajá,
Difusión de Ciencia y Tecnología, y el CDA, que es el Centro de Desarrollo Aeroespacial del Politécnico.
perfecto. Excelente. Entonces, estamos en comunicación a través de Ana. Cualquier cosa, déjenos saber a través de ella si tienen alguna otra duda. Y estamos en comunicación. Nos vemos la siguiente semana.
Disculpe,
Sí.
con respecto a las visas, bueno, yo hice una cita estándar,
Ajá.
pero me dicen que mi cita está programada para dentro de un año.
Ujú.
Entonces, yo no sé si hay alguna manera en la que se pudiera, pues no sé, apresurar o agilizar la cita para el trámite de la visa.
Hay unos encargados que le llaman gestores, no sé si los conocen. Los gestores lo que hacen, hay veces que ellos se encargan de que cuando hay alguna cancelación en el proceso de visas, ellos puedan subir el lugar. Entonces van como que dejando espacios y ganando espacios. Entonces, a lo mejor te pudiera convenir tener la ayuda de un gestor para que te esté monitoreando ese proceso. Nuestro equipo ha hecho, por ejemplo, del International Aerospace Academy, cuando hemos tenido proyectos y hay gente que ha venido, las tramita como visas urgentes también. Que eso hay veces que les ayuda un poquito más, pero también se ponen en contacto con el gestor y el gestor es el que hace el salto hacia arriba en la lista. ¿Qué más les iba a decir? Y bueno, sí, eso es más que nada el proceso.
Muy amable.
Ujú.
Yo
Thank you
también
very
tengo una
much
más
for all the
respecto a...
information. Ujú, ujú.
Hola, hola, ¿verdad? No sé si me escuchan.
Ajá.
Yo creo que a lo que se refiere la doctora, por ejemplo, cuando pues se participa en algún congreso internacional o algo así sobre de esta índole, normalmente otorgan una carta de participación. Entonces, eso facilita o incluso ayuda para poder hacer cualquier trámite de gestión de cualquier visa. Eso es a lo que creo que se refiere la doctora.
Ah,
No
ok.
para que agilicen, sino más bien para, entre comillas, asegurar la autorización de la visa,
Ujú.
porque con esa carta pues nos pueden ayudar a certificar que tenemos algún motivo por el cual tenemos que asistir a a ese curso en Estados Unidos.
Ok.
Entonces, si con esa carta nos pudiesen ayudar, creo que es bastante ayuda
Ujú.
para poder hacer la gestión de la visa. Cuando uno hace el trámite, incluso creo que puedes apuntar a algún documento de que tienes un trámite para algún congreso, para alguna visita, un curso o algo,
Ujú.
y le da prioridad para poder aceptar el visado.
Ok. Sí, hemos hecho nosotros ese tipo de cartas por medio de la organización de nosotros. Brian, they were asking about the Summer Institute. Like if there's like a letter of support that they will be coming, so some of them need like a visa to be able to come here. I
Right.
told them that through my nonprofit, we have been able to help people to come and get that letter. I don't know if you wanna elaborate more on that, like if you wanna do one specific for Mimic, or you want me to help them with that process.
Oh yeah, I think you're in a better position to help with that. We've not done that before, so you're going to be in a better place for that.
Okay.
If you need anything from me, definitely let me know though.
Ok, sí, entonces, para que no haya ningún problema, esa carta va a salir por medio de la organización de los otros para que ustedes puedan venir. Y ya hemos hecho eso varias veces.
Ok, incluso, bueno, tendrían que ir personalizadas o hacer una por grupo, que vayan nuestros nombres completos para que eso lo puedan identificar incluso o relacionarlo con nosotros a la hora de hacer el trámite.
Ajá. Sí, esas cartas las mandamos de manera individual y personalizadas también, con todos los datos la ficha y los datos de nuestra organización sin fines de lucro. Pero si quieren, le pudieran mandar posiblemente a Ana, quien pudiera necesitar ese proceso, y Ana me haría llegar la lista. Y con Ana necesitamos discutir la fecha para que ustedes vean más o menos cuándo pudiéramos hacerlo.
Está bien, Javier, gracias.
Ajá, a ustedes. Ok, well, thank you, Brian. Gracias, Ana. Gracias a todos por conectarse y nos vemos la siguiente semana.
Por acá también llegó el ingeniero Jorge Meléndez, que es también del Centro de Desarrollo Aeroespacial, que nos ha estado ayudando a coordinar todo esto. No sé si quieres decir algo, Inge.
Muchas gracias, Ana. Nada más agradecerles el apoyo, la orientación que están dando. Yo no estoy tomando el curso, yo simplemente estoy ayudando a coordinar tanto el seguimiento como las actividades referentes al curso, ¿no? Entonces, agradecerles el apoyo y agradecerles todo lo que nos puedan seguir apoyando.
Bien, muchas gracias.
Gracias.
Bueno, gracias a todos. Ahora sí nos
Thank
vemos.
you.
Gracias. Thank you.
Gracias, buena tarde.
Bye bye.
Bye-bye. Adios.
Thank you so much.